Okay, today we're going to go over part one of the review. I'm going to try to go pretty quick so that you guys can have more time to work. So on your mark, get set, go. All right. This is all chapter one stuff, so it should be in your composition notebook underneath chapter one. All this stuff that we've done is in chapter one. So I don't know the page numbers. I am recording this at home, and my composition notebook is up at school. So the first thing we're going to talk about is evaluating expressions. So if you have an expression like this, it's an expression because it doesn't have an equal sign. All you're going to do is you're going to plug in -2 for m, 3 for n, and 5 for p, and figure out what the value of all these operations are. So we're plugging -2, we have 2 times -2 minus 4 times n minus p, and is 3 minus 5 squared. Now the order of operations is PEMDAS, PEM, DAS. That's parentheses, exponents, multiply, divide, add, subtract. You always start in that order. So you always simplify parentheses first. So we would do this 3 minus 5. So you have 2 times a -2 minus 4 times 3 minus 5 is a -2 squared. The next thing, after you simplify what's inside the parentheses, then we do exponents. So we're going to do this exponent first. We're going to square -2. So we have 2 times a -2 minus 4 times -2 times itself. -2 squared is 4. So we got 4 times 4. Okay. So then we go up here. You got 2 times -2 is a -4 minus 4 times 4 is 16. And -4 minus 16 is -20. Okay, on your mark, get set, try this, pause the video, and go. Hopefully you got -37. If you have questions, ask. The next one, do you guys remember what these are called? Those are absolute values. An absolute value takes whatever's inside and makes sure it's positive. If it's a positive number inside, it stays positive. If it's negative, once you simplify what's inside, if it's negative, it changes to a positive. So this is going to be 7 times the absolute value of m times p. M is -2 times p, which is 5, and then we have -30. -2 times 5 is a -10, so -10 is inside the absolute value. That absolute value changes it to a positive, so that's going to change to a +10, a +10 on the inside. We'll still have a 7, and then we'll have a -30. Now notice how I changed the absolute value from an absolute value sign to a parenthesis, because once you take the absolute value of it, the absolute value of -10 changes to +10. You're done. 7 times 10 is 70, minus 30 is 40. Okay, why don't you guys try this, pause the video, and then come back to check it. Here we got 14 minus 2 times m, which is -2 minus n times p, so 3 times 5. 3 times 5 is 15, so we got -2 minus 15 in the absolute value. Okay, -2 minus 15 is a -17. Then we have this -2 out in front. Since there's not a sign in between, that means it's multiplying, and this 14. So here we have 14 minus 2 times, what's the absolute value of -17? Changes to a +17. Okay, a -2 times +17 is a -34. So we have 14 minus 34. It's a -20. Now notice the absolute value only changes what's inside. It doesn't change the -2 and the 14, only what's inside. And you can only change it after you've simplified what's in the absolute value. Okay. The next thing we're going to talk about is properties of real numbers. Again, this is in chapter 1, so if you've forgotten some of this, you can look back at your notes. This Q stands for rational numbers. The I stands for irrational numbers. The Z stands for integers. The W stands for whole numbers. And the N stands for natural. Okay. Rational numbers and irrational numbers. It's either going to be Q or it's going to be I. It has to be one or the other. It has to be one or the other. And then it could be the following ZWN. It doesn't have to be. Q means, well, let's just talk about I. An irrational number are the messy numbers. So that's anything left in a square root or pi. So irrational numbers are things left in a square root that you can't simplify. They have decimals that go on forever without repeating. Everything else is going to be rational. So if we look at all these numbers, let's first start talking about, are they going to be Q or I? So is that a nice, pretty whole number? Yes. So it's going to be Q. It's going to be a rational number. Okay. Let's look at this one. Do we know what the square root of 36 is? Yes, it's 6. So since it could be simplified, it's going to be Q. It's a rational number. Let's look at this one, -5. Okay, does it have a decimal place that goes on forever without repeating? No, that's what an irrational number is. Since that's simplified, it's a pretty number, that's going to be a rational number. Okay. And then this one, the square root of 7. Can you simplify the square root of 7? No. So that means it has a decimal place that goes on forever. It's going to be 2 point something. That'll go on forever. That's an irrational number. That's what I stands for. Irrational. Okay. So we decided if it was Q or I, that's what you do first. Then you go back and look, is it going to be a Z, a W, or an N? Okay. Integers are all the positive, negative, and 0 numbers. So integers are positive, they include 0, they include negative. Okay, these are integers. All the whole numbers that are positive, negative. So here, 0 is 0 integer. Well, yes, it's 0. Integers include 0, so we can put a Z here and we can say integer. Okay, let's look at 6. Is 6 an integer? Okay, well, since it's a positive whole number, yes, 6 is an integer. If it was a fraction, it wouldn't be an integer, but it's a whole number, so that's good. Here it's a -5, okay? Integers include negatives, zeros, and positive numbers that are whole numbers, so they're like not a fraction. So yes, this is an integer as well. Is square root of 7 an integer? Well, if we took it, it would be a decimal place that goes on forever. Since it has a decimal, it's not an integer. Okay, so this is not an integer. We can't put an integer there. Whole numbers are 0 and positive numbers that are whole numbers. Okay, so 0, is 0 a whole number? Well, yes, whole numbers include 0, so 0 is a whole number. Okay, is 6 a whole number? Well, since 6 is positive and it's doesn't have a decimal, it's a whole number. Okay, is -5 a whole number? No, because it's negative and whole numbers only include 0 and positive numbers. The next one, 7. Is 7 a whole number? No, because it's it has a decimal place. Whole numbers can't have decimal places. Okay. Natural numbers are just positive numbers, and they're like 1, 2, 3. They have to be whole numbers as well. They can't be decimals or fractions. So is 0 a natural number? No, because natural numbers don't include 0. Is 6 a natural number? Yes, it's one of the counting numbers, so we can say it's a natural number. Is -5 a natural number? No, because it's negative. And this one, no, because it's got a decimal place. So this one is QZW, QZWN, QZ, I. Those are all the sets of numbers that those numbers belong to. Okay. The next one we're going to talk about is solving equations. When you're solving equations, you're trying to figure out a value for x. So you're saying, what does x equal? So the next thing we're going to do to solve for x, you have to get x on the same side of the equal sign. So here's your equal sign. Whatever you do to one side, you have to do the other. So I try to get my x's together. I would probably move this 3x over to the other side. Since it's a positive 3x, we subtract 3x from both sides. Cross out the 3x. What's a negative 5x minus 3x? You got 8 negative x's, okay, equals 24. Okay. From there, we're trying to get x by itself. So what's happening between negative 8 and x? They're being multiplied. So the opposite of multiplication is division. So we're going to divide both sides by negative 8. Negative 8 divided by negative 8 is 1. So we're left with 1x. 24 divided by negative 8 is a negative 3. So we have 1x equals negative 3. Okay. Pause the video. See if you can do this. Where are you going to start? You're going to start with distributing and combining like terms. So we got 5m times negative 8, negative 3 times 2m, and negative 3 times 12. 5 times m is 5m. 5 times negative 8 is negative 40. Negative 3 times 2m is negative 6m. And negative 3 times 12 is a negative 36. All that equals a negative 84. Okay, here's your equation. So here's your equal sign. This is what we have to keep balanced. Okay, we have 5m's and we have a negative 6m. Since they're on the same side of the equation, we can combine them. 5m minus 6m is negative m. There's negative 1m. A negative 40 and a negative 36 is a negative 76. And that is equal to a negative 84. Okay. Whatever we want to do to one side, we have to do the other. So since we're solving for m, we're going to add 76 to both sides. That cancels. We have a negative m left on this side of the equation, a negative m, and then a negative 84 plus 76 is a negative 8. How do you get rid of a negative sign? Well, you can divide by negative 1. Negative 1 divided by negative 1 is a positive 1, or you can multiply. Either way works. Negative 8 divided by negative 1 is a positive 8, so m equals 8. Now we're going to talk about solving absolute value equations. Okay, absolute value equations. You have these in your notes. They're kind of crazy. There's a case 1 and a case 2. Before you do case 1 and case 2, you have to get the absolute value by itself. So we want that to be the only thing on the left side of the equation. So I'm going to add 5x to both sides. So I get the absolute value of 8 minus 3x is equal to this 5x plus 24. Once you get the absolute value by itself, then you have to split it up into two cases. Okay, the first case is you drop the absolute value. What if 8 minus 3x does equal 5x plus 24? The next thing is, what if 8 minus 3x equals negative 1 times 5x plus 24? Okay, so over here, you'll just solve the equation. Over here, you got to distribute that negative 1, so it turns it into a negative 5x minus 24. So it changes the signs of both of those. So you got an 8 minus 3x equals negative 5x minus 24. So from here, I need to get my x's together. So I can subtract 5x, subtract 5x. I get 8 minus 8x equals 24. I got to subtract 8 from both sides. So I get a negative 8x. 24 minus 8 is 16. Divide by negative 8. Divide by negative 8. And x is equal to 16 divided by negative 8. X is equal to a negative 2. That's for this first one. Okay, on the second one, you change it to a negative. So I'm going to add 5x, add 5x. Okay, sorry for that extra line. I got 8 minus 3x plus 5x, so that changes to a 2x. It's positive. So 8 plus 2x equals negative 24. When I subtract 8, I get 2x equals a negative 24 minus 8 is a negative 32. I divide by 2, negative 32 divided by 2 is a negative 16, so I get x equals a negative 16. Okay. From here, when you're doing absolute value, you always have to check your solutions, because sometimes both of them will work, sometimes one of them will work, sometimes none of them will work. So if I went to a new document on my calculator and asked for a calculate page, I would plug in negative 2 into my calculator. I'm going to take the absolute value of 8 minus 3x. So this is what I'm going to do. Your absolute value button is right here next to the 9. If you click on this, yours is probably highlighted on the fraction. You can go down one. It looks like a square with 2 lines beside it. That's your absolute value. Okay, we do 8 minus 3 times x, and what I found for x was negative 2, so I'm going to plug in a negative 2. And then I'm going to close my parentheses, and then I have minus 5x. So outside my absolute value, I'm going to subtract 5 times x, which I found was negative 2. Now once I plug this in, I'm hoping that it gives me 24, what my original equation was. When I hit enter, it gave me 24. Awesome. Negative 2 works. The next thing I need to check is, does that negative 16 work? So I go here. I'm going to plug in the same thing, except instead of 2, I'm plugging in a negative 16. So I have the absolute value of 8 minus 3 times x, which I'm plugging in a negative 16, close your parentheses, minus 5 times x, 5 times negative 16, close your parentheses, hit enter. That gives me 136. Is 136 the same as 24? No. So this negative 16 is not a solution. Okay, go ahead and try B if you don't know where to start. Wait 5 seconds. All right, here, this negative 3 is being multiplied times the absolute value, so we're going to divide it by negative 3. So we have the absolute value of 4x minus 9 is equal to 24 divided by negative 3, so that's negative 8. Once you get your absolute value by itself, that's when you can split into case 1 and case 2. Okay. Case 1 is that 4x minus 9 equals a negative 8. You keep it the same. Case 2 is, what if 4x minus 9 equals negative 1 times negative 8? Okay. Negative 1 times negative 8 changes it to positive 8. So we have 4x minus 9 equals a positive 8. Over here, nothing changes, so we can start solving. Here, we got plus 9, plus 9. You have a negative 8 plus 9. Oh, whoa, whoa, whoa. Before we even get there, that's how you would set it up and keep going. When you get your absolute value by itself, can an absolute value, when it's by itself, ever give you a negative number? Absolute values take whatever's inside and it changes it to a positive number. So if you get, if we work this out, we get 2 solutions, and what we'd find is they wouldn't work. And the reason why they won't work is an absolute value cannot produce a negative number. So if you get to this point and you notice that your absolute value that's by itself equals a negative number, there is no solution. And we went over that in detail when we went over absolute values. So there's our answer there. If you worked it out and you got 2 solutions and you plug them back in and neither one of them works, then you know it's no solution. You just did a little bit more work than you had to. Okay. The last thing we're going to talk about are solving single variable inequalities. Solve each inequality and graph the solution set on a number line. To solve an inequality, it's similar to an equation. You got to get your variables together, and you always want to move your variables to the left side. It'll work better that way in the long run. The only thing with this is if you divide by a negative or multiply by a negative, this inequality sign has to flip directions. We'll talk about what that is. So a couple things you want to know. If it's a less than or greater than sign, it doesn't have an equal to sign, you draw an open dot on your number line. If it's a greater than sign and or less than sign and it has equal to, that's a closed dot. Okay, if it's a greater than symbol, you're going to shade to the right. And if it's a less than symbol, you'll shade to the left. But in that case, in these cases, the variable has to be on the left side or else it doesn't work. So we're going to get our variables together. I'm going to subtract 3m. Here's my inequality sign, so this is what has to stay equal. We have to do it on both sides, so I'm going to subtract 3m over here. 3m minus 3m. Here's my inequality sign. We got a negative 2. We got a negative 10. 7m minus 3m is 4m. I'm going to add 10 to both sides. Here's my inequality sign. It's staying right there. Negative 2 plus 10 is 8, and that's 4m. So divide by 4, divide by 4. So that comes to m is greater than 2. If m is greater than 2, what I'm going to do on my number line, I'm going to plot 2 in the middle. I'm going to plot one number less and one number bigger. Since m has to be greater than 2, I'm going to have an open dot because it doesn't say an equal to sign, and I'm going to shade to the right because it's greater than. Okay, try the next two, see if you can get them. Here we go. Got to distribute that 2. We got 2h plus 46 is less than this 4h and the 10. You got to get your h's together, so I'm going to subtract 2h, subtract 2h. I get 10 minus 6h is greater than 46. I'm going to subtract 10, subtract 10. I have a negative 6h is greater than 36. From here, you divide by negative 6, divide by negative 6. When you divide by a negative number, your sign flips. So we have h is less than 36 divided by negative 6 is a negative 6. There's your number line. So, or there's your inequality. So we're going to start with the number line. We have a negative 6. Negative 5 is bigger because it's not as negative. Negative 7 is smaller because it's more negative. We're going to have another open dot because we don't have an equal to sign. If it was an equal to sign, you shade that dot in. And h is less than negative 6, so we're going to shade to the left. Okay, this last one, you have kind of a crazy fraction. Let's wait till that fraction's by itself. The first thing you're going to do is you're going to subtract this 18 right here. So you get 9x plus 5 divided by 4 is less than 26 minus 18 is 8. How do you get rid of this 4 that's dividing? What's the opposite of dividing by 4? Multiplying by 4. So if we multiply both sides by 4, these 4's cancel. The 8 times 4 does not cancel. 8 times 4 is 32. So we get 9x plus 5 is 32. I'm going to subtract 5 from both sides. So I get 9x is less than 32 minus 5 is 27. I'm going to divide by 9. Divide by 9, I get x is less than 27 divided by 9 is 3. There's my inequality. From there, you graph it. Notice all these are less, they don't have equal to signs, so we'll be using open dots on all these. There's a 3, there's a 4, there's a 2. Since x is less than 3, we're going to shade to the left. There is a very quick overview on Chapter 1. Review Part 1. Y'all should be able to, on your actual semester review assignment, from these notes, you should be able to knock out 1 through 14. I would highly encourage you to try to get 1 through 14 knocked out by tomorrow because you don't want to get behind on this. If you get behind, you'll have a lot of work to do right before the final. Have fun.